Right, let us continue. Things to remember in this next slide. Okay, still on chapter 6. We are looking at compounding frequency. Things to remember. You always need to make sure that the interest rate and the time period match. These two must match. If you're looking at annual periods, you need an annual rate. Okay, if you're looking at monthly periods, you need a monthly rate, which is quite obvious. But the thing that you need to note here, is the period compounding rate must match the payment or cash flow period. Always adjust the period rate to match the payment frequency, because you cannot adjust the payment frequency, but you can adjust the period rate. Okay, this period rate must match this. So the payment frequency will determine the period rate. So the equivalent period rate. So we'll look at some example a bit later. So this is important to adjust when you are faced with such a problem. Okay, if you have an APR based on monthly compounding, you are given APR, this is the yearly rate, and you are told that this APR is compounded monthly. So you have to use monthly periods for lump sums, or adjust the interest rate appropriately if you have payments other than monthly. So you have to adjust this. So that's the idea behind this. Let's look at an example here. Okay, let's computing the EAR. This is an example here. Suppose you can earn 1% per month on $1 invested today. What is the APR? Now this is a simple question, just like what we did previously. This 1% per month, this is a period rate. This is a period rate. That means 1% interest will be compounded in 1 month. Okay, and this $1 is just the present value now. Now the question is, what is APR? APR is 1%, the period rate, multiplied by how many periods in 1 year. So this is month, the period is month, therefore how many months are there in a year? 12. Therefore R multiplied by M, R is 1%, M is 12, therefore this is 12%. 1 multiplied by 12, you get 12%. So that is APR. How much are you effectively earning in 1 year? So when you say effectively earning, this is EAR. How do you get the EAR? We can simply use the formula. Here they compute the future value. 1 is the present value now, $1, multiplied by 1 plus R raised to the power of 12. Now this 1% is the interest rate for 1 period. So we are looking at compounding this 12 times, 12 periods, so you come to the end of 1 year. So 1 multiplied by 1 plus 1% raised to the power of 12 is actually the future value. This is the future value after 1 year. If you invest at 1% per month over 12 months. So it is 1.1268. Now if you want to determine the rate, it's actually this minus 1 that you invested in, your original investment, is the future value minus the present value divided by the present value. So you get actually 12.68%. Now this is the same as computing the rate that we saw earlier. We want to compute the EAR. EAR is actually 1 plus R. 1 plus R. R is 1%. Raised to the power of 12 minus 1. Minus 1. So it is 12.68%. This is EAR. Effectively you are earning not 12%. 1% times 12 is 12%. This is APR. But actually if you get 1% compounded per month, so in a year you are actually earning effectively 12.68%. Slightly more due to the compounding effect. Here we ignore the compounding. We just take the multiple, 12 times. But here, because interest, earlier interest will increase the later interest, and therefore because it is compounded more frequently, the effective interest rate goes up. Now let's look at this example here. Suppose you put it in another account, you can earn 3% per quarter. This is 1% per month. This is 3% per quarter. How many quarters are there in 1 year? There are 4 quarters. So 3, what is the APR? So you take 3 is the period rate R. How many quarters are there? Okay, 4, yeah, M is 4, therefore 3 times 4 is 12%. Okay, R multiplied by M, yeah. So it's also 12%, same, yeah, same APR. But how much are you effectively earning? This is EAR. Okay, how do you compute EAR? It is the same, yeah. You can take 1 plus R, 3%, 1 plus 3% raised to the power of M, 4 minus 1, yeah. Therefore you get 12.55%. Even though the APR is the same, okay, the APR is the same for two examples here, yeah, 1% per month and 3% per quarter. The APR is the same, but the effective rate, yeah, this is lower, this is higher. Why? This higher effective rate is due to higher compounding. Given the same APR, then an account has higher compounding, that means you compound once a month rather than once a quarter. Okay, the effective interest that you earn is higher, yeah, when you compound more frequently. So that is the what you call principle, yeah, that you need to understand from this. Okay, now given an APR, higher the compounding frequency M, higher will be your EAR. These are all EAR, yeah? These two, EAR. Higher the compounding frequency here, 12 times. Here it's only 4 times. Yeah? So therefore, this will always be greater than this. Yeah? Given that the APR is the same. Yeah? APR is the same for both. Therefore, higher the compounding frequency, higher would be your EAR. Yeah? So that's the impact of compounding frequency. Now let's look at decisions here. Another example. We are looking at two savings accounts. One pays 5.25%. This is APR. Note this, yeah. It doesn't say, but okay, you need to understand that this is APR. Yeah? And then comma, it says daily compounding. That this APR is daily compounding. Yeah. Another is 5.3. This is another APR, another account. Yeah. 5.3% APR with semi-annual compounding. That means it is only compounded twice a year. This is 365 times a year. Yeah, this is compounded 365 times. Note that this is lower APR. This is higher APR. They are not the same. Yeah, this is higher in APR terms. This is lower. But in terms of compounding, M, this is daily compounding. This is only semi-annual compounding. This is higher, yeah? Higher compounding frequency. This is lower compounding frequency. Which account should you use? In order to decide, you must always compare these accounts based on EAR, what you effectively earn. Yeah? So EAR with the first account is 1 plus, you need the period rate. Yeah? The period rate is actually APR. Okay, this is the APR divided by 365. Yeah? Note this. This is the R. Yeah? 0.0525, that is 5.25% in decimal. 0.0525 divided by 365. This is R. Okay, this is the period rate. Raised to the power of M. Yeah? M is 365, yeah? Because it's daily compounding. M is 365. Yeah? So you minus 1. Okay, you get 5.39%. Yeah? This is the effective interest earned for 1 year. Yeah? If you take this account, yeah? First account. The second account, okay, this is 5.35 divided by 2. Yeah? Why? Because there are 2 semi-annuals in 1 year. Yeah? 2 6 months. Yeah? Semi-annual means 6 months. Yeah? 6 months once you compound. Therefore, 0.053 divided by 2 is your period rate plus 1. You raise the power of 2. M is 2 here. So then you minus 1, you get 5.37%. Note this, yeah? This is higher and this is lower. Yeah? This is higher despite the lower APR. Yeah? The APR here is higher, this is lower. But because the frequency of compounding is high, this becomes higher here. Yeah? Right? Not necessarily. Yeah? Sometimes this is close enough, this is higher. Okay, let's say this is 0.55. Okay? And this is 0.525. Yeah, okay. Even if you do daily compounding, okay, this might still be higher. Yeah, right. So you need to test this first. Yeah, you need to compute this first and then compare. because the first account pays you a higher EAR, you should choose this. This is based on savings account, so you should choose the higher one because you want higher return. But if it is borrowing, okay, this is the interest that you need to pay, then you will choose this one, because this gives this will give you a lower cost. Okay, this is a higher cost, if it is a borrowing, but this is an investment, so you choose the higher return, the one with the higher return. Okay, so you should choose this because the first account gives you the answer here. You should choose the first account because it gives you a higher EAR. Alright, now computing APR from EAR. You can compute directly, or you can go through computing R first, R, or the period rate. If you have an effective rate, how can you compute the APR? You rearrange the EAR equation. We know this already. So EAR, okay, from EAR we can compute R. How? 1 plus EAR raised to the power of 1 over m minus 1. This will be R. Okay, this will be the formula for R. Then you multiply with m, you get APR. Okay, so it's quite simple. Let's apply this in this example. Suppose you want to earn an effective rate of 12%. This is EAR, when you say effective rate, 12%. And even if it doesn't say 1 year, you must assume, given interest rates, if it's not stated clearly, then you just assume it is for 1 year. And you're looking at an account that compounds on a monthly basis. So M is 12, because it's monthly compounding. What APR must they pay? This is the effective rate and it compounds on a monthly basis. What is the APR? Of course, if this is EAR, APR must be lower, because the compounding is more frequent than once a year, because it's 12 times. Before computing, you should know that APR must be less than 12%. But how do you compute this? First, you compute what is R. 1 plus 12%, this is EAR, raised to the power of 1 over 12, okay, minus 1. So you know that the period rate every month, okay, this is the period rate, okay, 0.94888. This is rounded to 4 decimal points, in percentage. Once you have computed R, then you multiply with M. APR is R, this, multiplied by 12, so it will be 11.3866%, about 11.39%. Okay, and this is less than 12. Okay, it must be, because the APR, once you compound, more than once a year, the EAR will be greater than the APR. So if this is 12%, APR must be less than 12%, and that is shown here. Is that okay? Right. Now we try and apply this in a more elaborate problem. Okay, computing payments with APR. You can't see the title here because I want to show you the computation here. Let's look at the example here. Suppose you want to buy a new computer system and the store is willing to allow you to make monthly payments. Okay, the entire computer system costs 3,500. This is the present value. This is the present value, PV. Right, the loan period is for 2 years. Okay, you cannot buy with cash. Okay, so you need to borrow. The term is 2 years and the interest rate is 16.9%. This is APR. This is the interest rate. Now this is APR with monthly compounding. So it tells you monthly compounding. The payment is monthly. So monthly compounding agrees with monthly payment. So the first thing that you need to do here, which you did not do previously, is you need to get the R, the period rate. Okay, all the R's that we have used were yearly, but here it is monthly. Okay, so you need to compute the R first. R is here 16.9% divided by 12. Okay, why 12? Because there are 12 months in a year. M is 12, because it's monthly compounding. So you divide this by 12. This is the monthly rate, in decimal. Then the second adjustment that you need to make is number of months. Yeah, this